Hello, I'm Steven, and I will be walking through the Clemmensen reduction today as my presentation topic. This reaction is first discovered by Danish scientist Eric Clemmensen, who worked for a pharmaceutical industry company in 1900. He developed a method for the manufacture of sodium benzoate, vanillin, and coumarin. He also developed the synthesis of artificial saccharin while he was working in Monsanto. He is most commonly associated with the Clemmensen reduction, which is what we are going through today. Here is the sample mechanism of this reaction. In short, it is a method of converting a carbonyl group into a methylene group by using zinc amalgam and HCl. In this reaction, the reason why we use zinc amalgam instead of the powder of zinc metal is the metallic zinc can be activated by mercury by dissolving it into individual atoms of zinc that can be distributed evenly in the alloy. So zinc amalgam performs in this reaction as it is a solution of zinc. I will be talking through the specific mechanism of Clemmensen reduction in three steps. First of all, the carbon can be activated by the H+, which acts as an acidic media. Because the carbon is less capable towards the nucleophilic attack, so in order to increase its electrophilicity, the H+ will attack the oxygen atoms and gives this structure here. Now the oxygen carries a positive charge, so the pi bond between the carbon and oxygen will break, and these electrons will move towards the oxygen atom. Now the carbon will gain positive charge, so the carbon here is more electrophilic than the carbon on the left, where we begin. The next step is when zinc loses 2 electrons and converts it into zinc 2+ and 2E-. Now these 2 electrons will attack the positively charged carbon atoms and convert it to this carbon here. Now the acidic media provides the H+ ions to both carbon and oxygen here, and we will get this structure like this. For the last step, the H2 molecules departs as a leaving group, and we will get a carbon cation presented. Zinc will lose 2 electrons and convert it to zinc 2+ and 2E- again, and these electrons now will be taken by the carbon cations here and converted into carbon anions. The acidic media will then join the structure, and we get the alkane at the end. On the right is an example of the Clemmensen reduction used in industry. However, Clemmensen reduction reaction is not suitable for substances sensitive to acids, like the substrate must be unreactive to the strongly acidic conditions of Clemmensen reduction. Also, the carboxylic acid group cannot be reduced by this method, but the COOH group can be reduced by treating it with soda lime and then heating again. For reducing acid-sensitive substrate, Wolff-Kingshire reduction is suitable, which is another method similar to the Clemmensen reduction. This will be the end of my presentation, and I hope to see you all soon. Thank you.